Welcome in to a new podcast from Materials Performance Magazine. My name is Ben Dubose, news editor with the AMP Publications team. Today, I'm joined by Ian Kinnear, product manager with GPT Industries. Ian, good morning. Thanks for taking the time. How are you?
I'm doing wonderful, Ben. Thank you so much for having me. We're really looking forward to being here today and really appreciate being here. How are you doing?
Oh, can't complain. Glad to have you. And for our listeners, in this episode, we're going to be looking at some of the challenges facing corrosion professionals in 2023, and quite frankly, beyond that as well. In particular, we're going to be looking at cathodic protection trends and the various challenges related to that as it pertains to the oil and gas, water, and emerging energy industries. GPT is a prominent manufacturer of isolation gaskets, kits, and isolation joints used to mitigate corrosion and enhance CP methods. The company's products primarily serve two functions: to seal and to stop electrical current. Ian, I think a good place to start, if we could just tell our audience a little bit about GPT and its history within corrosion prevention. Just a little bit of background on the expertise that you all have in this field.
Yeah, absolutely. I'm very happy to. So GPT is the leading and the largest manufacturer of flange isolation kits and monolithic isolation joints. And so it's been really our focus, our niche, and what we specialize in for over 30 years now. And it's something that we really take a lot of time, we really take a lot of pride in. Within our facility, which is located in Denver, Colorado, we do full manufacturing of both the flange isolation kits and the monolithic isolation joints. But to go along with that, we have a full engineering team with a full engineering test lab. So we can do sealing tests, we can do corrosion salt spray tests, we can do hydro tests. So we also have a cathodic protection loop on our facility where we can do mock CP systems, and we can really dig into the details of understanding kind of the nuances of that corrosion industry. And so we take a lot of pride in not only the manufacturing, but also the research and the development, the innovation, and really that deep understanding of what's happening within that corrosion cell, what's happening within our kits, and what's happening on the line. So kind of with that, we have kind of our all-in-one facility here with the full engineering team, full R&D, and full manufacturing. And so at GPT, we're really proud of being able to do that and being able to share what we learn with everyone as well. We're pretty fortunate to be able to get a lot of requests in, a lot of applications in, a lot of challenges in. And we like to talk to our customers and those in the field to be able to learn and be able to share that with the industry whenever we can, so that we can all have better systems and safer systems moving forward.
So for those unfamiliar with isolation kits and isolation joints, what function do they serve?
Yeah, and I think you gave a really good breakdown to start. So first, and I like to start off with this. So isolation kits come with isolation gasket, isolation sleeves, and isolation washers. And the first and main function of these is to seal. So the gasket goes between two bolted flange assemblies, or you have a monolithic isolation joint, which gets welded into the pipeline. And the first function, and I know what we'll talk about later, is that these have to seal the fluid going through your pipeline. So these are coming at a connection point, and at those connection points, we have to create a seal. And I always say corrosion's a slow process. Not being able to seal is an immediate big issue right there on the spot. So our isolation kits and our monolithic isolation joints, first and foremost, have to create a seal at that connection point. Their other purpose and why they are pretty unique from other types of gaskets and other types of seals is that corrosion mitigation that you mentioned before. So both of them electrically isolate one side of the line from the other. So you put our kit in, or you put the monolithic isolation joint in to electrically isolate one side from the other, so that current cannot pass from that one side to the other. And the reason that you do that is typically at a high level for two reasons. One is for galvanic corrosion. So if you have dissimilar metals being paired up with one another, you will put that kit in to mitigate one of those metals corroding away at a much more rapid rate than it typically would. These isolation kits or joints, monolithic isolation joints, will break up the metallic path between those two metals and mitigate that corrosion from occurring. The second main function, and this is probably what it's used for very frequently, especially in North America, is for cathodic protection. So cathodic protection is a means of mitigating corrosion in kind of that long structure of a pipeline, typically when your pipeline is carbon steel. And this is done typically by putting some form of current or some form of anode onto the line, and raising that whole line to a level where it doesn't corrode away at its typical rate any longer. Where isolation kits then come into play here is really sectioning off where that cathodic protection is taking place, so that it can be effective. You don't want that cathodic protection spanning too far on the line, and having to travel too far, and be able to do too much. You might have places with custody transfer. You might have places where you're entering a facility and you don't want current going into that facility. You may want to make sure that current doesn't jump off your line onto someone else's line. For a variety of reasons, you want to make sure that that current stays exactly in the section that you want, and you section that off by a flange isolation kit or a monolithic isolation joint. This is also done typically when you go below ground to above ground. You'll use an isolation kit at that point to make sure your current doesn't travel up the line above ground. And so kind of those two big functions of flange isolation kits and monolithic isolation joints are, first is to seal, and second for that corrosion mitigation, in the form of galvanic corrosion mitigation or making your cathodic protection systems more effective by segmenting them off for whatever reason that may be.
So I was going to ask you about some of the challenges facing pipeline corrosion professionals. I think you already touched on some of those. So I'll go a little bit deeper. How does the material or media that goes through a pipeline potentially affect that corrosion?
Yeah, it's a great question, and it's one of the major challenges, like you mentioned, that are facing our corrosion professionals right now. In the past, we were typically working with applications that were much more standard in the form of our traditional oil, our traditional hydrocarbons, our fairly clean natural gas. And as we dig deeper, as we have to find more and more reserves, we're finding these applications where we're getting much more challenging media. It's not as clean any longer. And this first affects our materials itself because our material has to be compatible, whether it's the pipeline material, the sealing material, the flange material, our gasket material. Our material has to be chemically compatible with what's going through the line. And when we start dealing with more and more challenging medias, that becomes more and more of a challenge. And so that's kind of the first major challenge that we see with this corrosion is if our material isn't chemically compatible with what's going through the line, it makes it challenging in that way. The next is that some of the media going through the line itself can be corrosive, or it can be conductive, and these kind of create their own challenging applications within themselves. Corrosive media is now going to make all our materials corrode away at a quicker rate. Conductive media might carry the electrical current from one side of the flange to the other and kind of bypass our flange isolation kit. And it's something that we have to be aware of. And then the last is when we're dealing with sour gas, and I think we're going to touch on this more as we go. Sour gas can really have an effect on the wall of the pipeline, and start taking off that carbon steel and making iron sulfide within the line. And this media is very conductive, and just it creates challenges further than that, and it mitigates our wall thickness in our pipeline longer. So having that corrosive material is definitely a challenge, material wise, and then just actually it causing degradation to our materials as it travels through the pipeline.
Let's follow up on that because according to the IEA, the International Energy Agency, above 40% of global gas reserves are sour these days. Have you all seen evidence of that? And what challenges do those types of sour conditions pose that a pipeline professional probably needs to think about?
Sure. And I'll tell you what, Ben, I think 40% is probably that number's going up. And I would think it's going to continue to go up. And it's kind of a global phenomenon that we see. And to answer that first question, we've seen lots of evidence of this. We see applications now from when I started about 6 years ago. I was seeing sour applications. People reach out with sour applications. I don't know, once every couple weeks, maybe. To where I am today, we're taking them truly daily. So we're seeing these sour applications, and that just means that we're dealing with hydrogen sulfide, and that's typically within our natural gas systems. And again, where we're having to pull up the natural gas from beneath in our Earth's core, there are now just sour gas beds. We're having to get that natural gas from places where sour gas is present. And so we're seeing it quite often. And sour gas and H2S, hydrogen sulfide, is a really challenging material. And anyone who's kind of part of the industry has probably had to go through H2S awareness classes because of how challenging of a material it is. The first is that if human beings or any type of living being takes any type of H2S in, it's incredibly dangerous, and it's very lethal. And so we can't have any times where we're breathing in this hydrogen sulfide. And so the first challenge from our perspective, being looking very specifically at seals, is that we have to make sure in our sour systems we're creating the tightest possible seal, because we can't have this leaking out in any way because of the toxicity and the lethalness that it'll cause within the industry. And so that's kind of the first thing that first comes to my mind. But then further than that is sour gas creates a lot of challenges with chemical compatibility. So it's a very challenging media to get material for. A lot of our typical steels are not rated for sour gas service. They'll go through a lot of sulfide cracking or other things where that sulfide actually penetrates that steel and cracks it. And you lose ductility, you lose strength within the steel being able to do so. Our other sealing materials a lot of times are also not suitable for sour service. So in the isolation world, the most common isolating material is called glass reinforced epoxy, GRE. That's the material that's kind of used as an industry standard. The challenge with this is it's a permeable material. So that at high enough pressures, you're actually going to penetrate that sour gas into the body of that glass reinforced epoxy. And over time, you begin to break the bonds. That sour gas is able to start breaking your epoxy bonds. And we've actually done quite a bit of testing on this, and I'm happy to share some of the results we had. But we saw that with sour gas and glass reinforced epoxy, after some time, your glass reinforced epoxy is going to increase its mass and increase its volume, which tells us that it's taking in that H2S, those sour molecules in a sense. But it's the density of that glass reinforced epoxy drops pretty significantly, which tells us that we're taking it in, but we're actually breaking those epoxy bonds down and softening that material. And over time, that can lead to bubbling, that can lead to softening of the material, and then down the line a leak. And so the challenge of sour gas there is really that chemical compatibility aspect. Making sure our seals, making sure then our elastomeric seals within the gasket itself has to be compatible as well, which is also a challenge. And then the last is what I mentioned is when sour gas is going through, it'll react with the iron in a carbon steel pipeline and create something that's called iron sulfide. This is also known as black powder. And anyone who's pigged a line that's has sour service in it knows exactly what I'm talking about. This black powder travels through the pipeline and it's an incredibly conductive material. Where this comes in as a challenge within our world is that we're trying to electrically isolate one side of the line from the other with our flange isolation kits. When we have a really conductive material, it can pass over, it can actually build up right where our flange isolation kit is, and the current on the line can actually just jump our kit. So our kit can be installed perfectly, be working exactly as we intend it to be, but its effects are mitigated because the current actually passes right through this very conductive iron sulfide material.
Yeah.
And this is something that we're seeing much, much more often. And GPT's taken kind of a really large effort in supporting this and trying to mitigate it. And we've had quite a bit of success in doing so with both our ID seals. So using gaskets that have an ID seal, which first don't let that material build up because you have a non-stick surface, and also increase the effective isolating distance, the area that you have to jump across with that conductive material. This is where monolithic isolation joints also play a big part, is that they really increase that effective isolating distance by being internally coated, and really help mitigate these effects. But before getting too carried away, those were kind of the big reasons that sour service is a challenge. It's something that we can overcome, but we have to make sure that we have the right systems in place because there's no options to have a failure when we're dealing with sour service. So it's something that we just have to work on and figure out as we go.
So at MP and certainly within AMP, we talk about not just corrosion prevention, but protective coatings as well. Of course, protective coatings, one of the primary means of corrosion resistance for a lot of operators. How do some of these technologies that you're talking about perhaps utilize or complement the use of coatings?
Yeah, it's a great question. And we both utilize and complement with coatings. And so I'll start with the complement side. So when I talk about cathodic protection, just like you said, in almost all of our systems, we are coating our systems now, right? So our pipelines get coated to help with this corrosion mitigation, kind of that first barrier, that first break off point of corrosion mitigation. But when we bury our pipelines, it's very hard to bury your line without having some level of imperfection, some level of impurities within that coating. And so where cathodic protection comes in is actually making sure we are protecting those holidays, those breaks in the coatings that we're going to inevitably see when we bury a pipeline. And then our products work to help section off where that cathodic protection is actually going. So our products work as a complement for the coatings in a very similar way that cathodic protection works as a complement to coatings. You use both of them in conjunction with each other to make sure you have the most effective system. Further than that, our products, so GPT recently, well, not so recent any longer, actually. It's now been coming on about 3.5 years, developed an isolation gasket that actually utilizes a coating itself. And we took away that glass reinforced epoxy that I was speaking about previously. We took that away to get rid of that permeable material and now instead use a highly abrasive, highly engineered, highly designed coating that can hold up to the pressures of a bolted flange assembly. And that can hold up to the rigors of what we need from a dielectric strength and an isolation perspective. And so we actually, in our facility here in Denver, Colorado, we coat our evolution gaskets in-house here. And this is something that we've built up and worked very hard on, is to get the capabilities in order to coat. And in order to do this, in addition to that, our monolithic isolation joint also utilizes an external and an internal coating. So we will externally coat our monolithic isolation joints, which go into the pipeline, to ensure that you don't have any corrosion on the outside of your pipeline. So as a typical coating would act on a line, we exteriorly coat our monolithic isolation joints, but we also internally coat them. And this is to help with kind of those effects that I was looking at before of increasing that effective isolation distance so that you have to make a much longer jump in order to get any electrical bridging from one side of the flange to the other. In this case, from one side of the joint to the other. So with our monolithic isolation joints, we internally and externally coat and do that all in-house as well under a controlled process, all under our GPT manufacturing roof.
So when we look to the future, reducing greenhouse gas emissions, that's obviously a huge priority for the energy sector. You're hearing more and more about hydrogen and carbon capture technologies becoming more of a priority. I guess holistically, how does corrosion prevention need to adapt to those needs? And from a GPT specific perspective, how are you all supporting those efforts?
Yeah, and it's a great question. And to kind of answer, I feel, as a product manager here and just working working within AMP, working within our industry, attending as many shows as possible, I feel that we need to be able to support where we're moving towards in the future. And where we're moving towards is a more emission-based focus world. It's finding different sources of energy, supporting different sources of energy, supporting better and more efficient ways to retrieve our energy, transport our energy, store our energy. And so from our perspective, I feel that I need to have products and have solutions that support all of this. So to start reducing greenhouse gas emissions, we know how much more important emissions and reducing the impact on our environment as a whole is becoming. And when we look at that, really every little bit does count. Everything that we can do makes an impact. And being able to create seals within our transportation lines or our wellheads or our downstream applications, being able to create the tightest seal possible is incredibly important. And it's something that is now being monitored, being incentivized, being looked at. And so from our perspective, it's why I wanted to start this podcast off with highlighting the importance of sealing. So a lot of times when we look at our applications, we're looking very deeply at corrosion mitigation. But I want to make sure we have that focus on sealing first, right? We have to be able to create a tight seal. And so at GPT, we've worked really, really hard on creating the best sealing solutions. So even if we go away from isolation, I believe we do actually have the best sealing gasket as well that we can provide in our Evolution gasket. It uses a pretty unique design of dual seals, which really work with a level of redundancy with each other, and have created what we've tested to be through and through in lots of different industry standard tests, an incredibly tight, low emission sealing gasket, and kind of the best one that we've tested so far. Further to that, we're moving towards finding other ways to produce energy, finding more emission friendly, efficient ways, just like you said, with hydrogen production, with carbon capture, which works hand in hand in a lot of times with hydrogen, but also in other applications where we're actually capturing that carbon and storing it instead of releasing it to our atmosphere. And in all of these applications, even, LNG is still fairly new. This is another way to transport energy, but LNG, hydrogen, carbon capture and storage, these are all now unique applications that provide their own unique challenges, their own, nuances that we need to account for. And a big challenge with these is they're moving fast, and a lot of the testing and regulation and understanding kind of follows suit with that. So at GPT, what we want to focus on, and I am happy to talk and do presentations and share with anyone the findings that we find within these, is getting that understanding ahead of time and as soon as we can, and providing the best, most innovative, kind of best in market solutions to mitigating any challenges before they happen, being proactive with them as opposed to reactive, and really just understanding where those nuances in each come. Hydrogen, hydrogen has a lot of potential for our energy moving forward, but when I'm as a sealing manufacturer, as someone who focuses on sealing, there's nothing more challenging to seal than hydrogen, right? So we need to get ahead of that and understand, hey, what products, what solutions can we make to help ensure that these hydrogen applications are most effective. And so with all of those, we're looking and we're working and having a really big focus on providing solutions to be able to do just that, and put kind of those best in class products into all those services that we're looking at moving forward.
So before your current role, you were an applications engineer. What were some of the application related challenges that you saw and that you try to incorporate in your current role now, as you obviously try to serve that audience to an extent?
Yeah, and I feel really fortunate for being able to be in that role, for the amount of time that I was as well, because in that role, I was able to take in if there was any product failures, whether it was GPT's own or our competitors or kind of anything in the industry. A lot of times those would funnel through me, and I would be able to really see what happened, what occurred, why did it happen, diagnose, and then put resources together. So again, this doesn't happen again. We can be more proactive instead of reactive. And one of the biggest challenges that I saw is kind of the lack of training and the lack of standardization of installation of these kits themselves. So installation errors caused, I would say, close to 85% or so of the failures that we saw kind of industry wide with the products that were being put in there. And this challenge of installation it's no one's fault. There's no much industry standard. There's no industry training or certification that you could get at that time for flange isolation kit installation. Similar, like welding, you have a lot of certifications that you go through, a lot of things that you have to do in order to do it. But with flange isolation kits, you don't have that. And so we did create an installation program that we have virtual and in person, where we actually do train and certify on flange isolation kit training as a result of this. And that was just one example that came to mind of things that I saw being quite a challenge in the industry. And then COVID hit, and we got even less resources and less human capital. And we needed projects to be done faster and cheaper and everything in that nature. And so installation became even more of a challenge. That's just one of the things as an applications engineer I was able to notice, and we were able to build upon. In addition, electrical bridging, like we talked about before, so conductive media, seeing that change from that not being an issue to all of a sudden that being a significant issue, and trying to find solutions to help mitigate that. Testing, do people understand when to test, how to test, what to look for when they do test? Because flange isolation kits and monolithic isolation joints are expensive, and that's because they serve many different purposes, but we want to make sure that we're actually testing for those purposes and understanding what goes into them. And so as an applications engineer, it was really nice to be able to see all that incoming information and challenges and failures and questions and be able to kind of compile it and create solutions as a result of that.
So it's been fairly widely reported that there's a declining amount of experienced engineers in our industry. And I'm asking this to you more as just a comprehensive overview, since I know you have this in your background. But I guess, first off, how much do you notice that type of shortage when you look at some of these challenges that we've been discussing for the last 30 some odd minutes? And I guess as an offshoot to that, how do you encourage members of the new generation coming through to potentially step up and fill that gap?
Yeah, and it's really interesting because how I noticed this first is kind of that lack of experience or just lack of people in general is that everybody's so busy, right? It's just anytime you get on a call with anybody, try to communicate with anybody in our industry or really any, you just notice how much everybody has on their plate. And it's just that lack of pure resource, kind of as an industry whole. And that leads to places where we're not able to do as much research. We're not able to do as much vetting, as much digging into the details as I think we probably would like to as an industry. And so it just creates a challenge in that regard. Um, in addition, we have been seeing a lot more young engineers, as you talk about. So there was that when COVID hit. I think we saw a lot of people that were maybe close to retirement, and especially maybe within that engineering sector, that was kind of the push to go towards retirement. And so anytime that happens, we have a lot of knowledge, a lot of just industry practice, common methods, whatever that may be, get lost in a sense, right? So it gets pushed out and it's sometimes hard to translate. And so it's just a lot of learning, a lot of understanding. And what I would say is to the young corrosion professionals is, well, if you're listening to this podcast, you're already well on your way, right? Is utilize the resources. The corrosion community has absolutely blown me away at how supportive, how the depth and the breadth of kind of through and through what we see in this industry. AMP is just it's an incredible organization that has so many different resources, so many different places for trainings, for seminars, for talks, whatever it may be. I would just absolutely say utilize those, take those seriously, meet people, talk to people. As a community, this corrosion community is really welcoming and wants to spread that knowledge that we've gained, that we understand, and help out. It's more about making the whole world better, right? Helping fight the challenges of corrosion and put the best systems forward, the safest systems forward that we can. And spreading that knowledge is how we do it. And so I've been very fortunate and being able to do that, to go through when I first started going through it, there was the NACE classes, but now the AMP classes and the conferences and the trainings and the seminars and my local chapter and being able to speak at other chapters and learn from people who are doing that. And so just being as involved as we can. And we're continuing to generate more, create more classes, create more interest at the technical college level, at the education level, to just teach people about corrosion and teach people the opportunities that are out there. And so really just encourage that. And it's exciting. A new generation of relatively young corrosion professionals creates a lot of opportunity as well. It creates a lot of opportunity to put our best systems in and reevaluate what's been done and challenge the norm and do all of that. So I think it really is exciting. But it's something that we just need to be aware of, and hopefully we all have resource and time to be able to do these things as we move forward.
Absolutely. Great advice there. Folks, he is Ian Kinnear, product manager with GPT Industries. Ian, before we let you go, for any listeners that want to learn more about GPT or perhaps get in touch with you guys, what's the best way they can do that? I'm assuming it's simply going to your website, but just plug whatever you want to plug from GPT's perspective for any of our listeners that may want to learn more.
Yeah, and I really appreciate that. And so our website, just like you mentioned, that's kind of the all-encompassing. We've got everything on our website in different places that you can navigate, and that's just gptindustries.com. And from there, you'll be able to get contact information. You'll be able to get anything technical, commercial, see the products, get some of that educational background, be able to go through some of our portals. So that's the best place to do it. We also have personal emails. You'll see mine on the website, ian.kinnear@gptindustries.com. We have an engineering email if you have technical questions, which is gpt.engineering@gptindustries.com. And these are really the places that we can look out to try to get in contact with us. We have a LinkedIn page, so we post there frequently when we have upcoming webinars, when we have upcoming trainings, when we have new case studies or new anything like that. So please follow us on LinkedIn. And then we do a lot of webinars, just educational, here's what we see in the industry type of webinars. And if you're following us on the socials or part of our website or newsletter or anything like that, you'll be able to see when these are coming. And I think they're really beneficial. We get great turnout for it. And so we really encourage anyone, if there's a topic that piques your interest or a topic that you would like to see, reach out and you can come to us. But yeah, we look forward to hearing from you and helping in any way we possibly can.
Absolutely. And I'll vouch for the webinars. I've listened to a couple, and yeah, there's very valuable info, not just related to the company, but overall just level of industry expertise and background knowledge. I think it's useful to people at a lot of different levels of corrosion prevention. So yeah, I'm right there with you. I endorse that. That's a good resource to potentially take advantage of.
Thank you so much.
Absolutely. Happy to. Thank you for joining the pod. And with that, we'll bring this episode to a close. Ian mentioned where you can get in touch with GPT and take advantage of some of their resources. For us at Materials Performance and AMP, our websites are materialsperformance.com and ampp.org. That's the website for the Association for Materials Protection and Performance, where I'm the news editor. Got all sorts of information at amp.org related to education, standards, publications. We've got so many great things going on within our association. You can find out information about all of them at ampp.org, amp.org. With that, we will wrap up. For Ian Kinnear of GPT Industries, I'm Ben Dubose, news editor of AMP. Thanks as always for listening, and please come back soon for another new podcast.